Hello everyone, welcome back to my YouTube channel. In today's video, we are going to discuss about Unit 4 of Database Management System, which is Transaction Processing Concepts. So in this unit, we talk about transactions, what is asset properties, and serialization. These are the topics covered in this unit. So let's begin. The first topic will be transaction concept. What is transaction concept? So a transaction concept refers to a sequence of one or more operations performed on the database as a single logical unit of work. Alright, so transaction is basically multiple operations performed on the database as a single logical unit. Okay, just such as read, write, update, and delete. A transaction ensures that either all operations are successfully executed, that is committed, or none of them take effect, right? Rollback. Transactions are designed to maintain the integrity, consistency, reliability of the database even in the case of system failures or current access. Transaction when a user perform a money transfer, several operations occur as reading the account balance of sender, writing the deducted amount from the sender's account, and writing the added amount to the recipient account. So this is the process that is performed when money is transferred from one account to another account. The next topic will be asset property. This is very important topic. The transactions are fundamental operations, as we all know, that allows us to modify and retrieve data. However, to ensure the integrity of the database, it is important that these transactions are executed in a way that maintain consistency, correctness, and reliability even in the case of failure or errors. Alright, as we know, transaction may be failures, so some occurs are happened sometimes. So to correct them, to maintain consistency, we use these properties. So this is where asset properties come into play. So this is asset property in Dbms. A stands for atomicity, means all or nothing transaction. All right, either the transaction will happen, otherwise if error occurs, then transaction stop there. All right, and C stands for consistency, which is valid state maintenance. I stands for isolation, which is transactions do not affect each other. D stands for durability, permanent changes after commitment. So this is asset property. Let's understand in deep. The first will be atomicity, which is haste A. Alright, A from asset. So atomicity means a transaction is all or nothing, either all its operations succeed or none are applied. If any part fails, the entire transaction is rolled back to keep the database consistent. So that is why I use this in DBMS. The commit means if the transaction is successful, the changes are permanently applied, so then this is known as commit. Alright, like successful transaction, if the transaction going to be successful, then this is known as commit. And if the transaction is occur some error or some like discard, then it will known as rollback or abort. So if the transaction fails, any changes made during the transaction are discarded, so this will known as rollback. So this is the atomicity property in DBMS. The next topic will be consistency. Consistency is in transaction means that the database must remain valid state before and after a transaction. So it maintains the validity. Valid state follows all defined rules, constraints, and relationship like primary key, foreign key, etc. If a transaction violates any of these rules, it is rollback to prevent corrupt or invalid data. If a transaction deducts money from one account but doesn't add it to another, it violates consistency. To maintain this, we use consistency property in DBMS. The next property will be isolation in asset property. Isolation ensures that transactions run independently without affecting each other. So isolation ensures independency without affecting each other. Change made by one transaction are not visible to others until they are committed. It ensures that the result of current transaction is the same if they were run one after another, preventing issues like these are the issues which may occur. Dirty reads means reading uncommitted data. For example, if money is transferred from A account to B, and if the money is not fully succeed or fully transaction will be not succeed, and it's shown to the transact account B, then this is known as dirty read, means reading uncommitted data. If the commission is committed is not done, then reading uncommitted data is known as dirty read. Non-repeatable data or reads, which means data changes between two reads. And phantom reads means new rows appear during a transaction. So this is isolation property which is used in DBMS to make independency without affecting each other. The next topic will be durability. Durability ensures that once a transaction is committed, its changes are permanently saved. If a transaction committed means if money transferred from one account to another account and this will successfully happens, then it change permanently saved. Alright, even if the system fails, the data is stored in non-volatile memory, so the database can recover to its last committed state without losing data. So this is known as durability. For example, after successfully transferring money from account A to account B, if the changes are stored on disk, even if there is a crash immediately after the commit, the transaction or transfer details will still be interact when the system recovers, ensuring durability. So these are the asset properties of database management system, which ensures durability, consistency, isolation, and atomicity. The next topic will be transaction state in database. What is transaction states? So transaction states represent the data phases a transaction goes through during its life cycle in a database, like how the transaction will happen from starting to end. These states help track the progress and outcome of transaction to ensure data consistency and integrity. So in those units, we only focus on consistency and integrity of the data or database. Alright, so different type of transaction states we have in DBMS. These are the different types of transaction state. The first state will be active state. The second state will be partial committed state. The third state will be committed state where transaction may be successful, and failed state where sometimes failure occurs. Aborted state and terminated state is the last state of transaction states. So let's begin. This is the life cycle. This is the as we study life cycle of database system, how the transaction occurs. Active state, partially committed state. All right, if read or when we read or write the operation. If failure, then failed, we move to failed state. If partially committed, if we move to partial committed state. And if we we are failure, then we move to failed state. Otherwise we permanent, we move to permanent store where committed state, where transaction gets successful. All right, then we if we are in failed state, the rollback occurs and we move to aborted state. And if you are in committed state or aborted state, the last state will be terminated state where the transaction may be terminated. All right, so these are the life cycle. This diagram is very important. The first state will be active state, which means it is the first stage of transaction when it has begun the execution. All right, the execution of transaction takes place in this state. Operations such as insertion, deletion, or updation are performed during this state. During this state, the data record are under manipulation and they are not saved to the database. Rather, they remain somewhere in a buffer in main memory. So this will be the first state where the transaction starts, and here the operation occurs like insertion, deletion, updation. These operations are performed there. So during this state, the data may be not stored there and under manipulation. The next state will be partially committed, where the transaction has finished its final operation but the changes are still not saved to the database. Like we transfer the money but this will not stored in database. So this is the state where which is partial committed. All right, after completing all read and write operation, like we transfer the money, we write there, but committed means successfully transaction occurs. All right, so operation, the modification are initially stored in main memory or a local buffer. If the changes are made permanent in the database, then the state will be changed to committed state. If the transaction may be successful and the data is saved in the database, then this will be in the committed state. This will happen in the committed state. So, and in case of failure, it will go to the failed state, as I told you in the figure. So the next state will be committed state, which is The state of transaction is achieved when all the transaction related operation has been executed successfully. When the transaction executed successfully, this will happen in committed state, and this will save the data in permanent storage. Along with the committed operation, data is saved into database after the required manipulation in this state. This marks the successful completion of transaction. So this is main state, which is committed state, where transaction get successful completed and data has been stored in the database permanently. The next state will be failed state. If you are making a transaction and it get failed, then this will comes in this state. If any transaction related operations cause an error during the active or partially committed state, further execution of the transaction is stopped and it is brought into a failed state. Here's the database recovery system. Make sure that the database is in a consistent state. The next topic will be aborted state, which is state when we committed then move to the aborted states. So if a transaction reaches the failed state due to failed check, database recovery system will if we this will come when we are in a failed state, then move to aborted state. So if recovery is not possible, the transaction is either rollback or cancelled to ensure the database remain consistent. In the aborted database, in the aborted state, the database recovery system performs one or two operations. First, kill the transaction or restart the transaction. So the system terminates the transaction to prevent it from affecting the other operations, and restart transaction after making necessary adjustment. The system revert the transaction to an active state and attempts to continue its execution. The last state will be terminated state. If you are committed or if you are in aborted state, then move to the last state, which is terminated state. It refers to the final state of transaction, indicating that has completed its execution. Once a transaction reaches this state, it has either been successfully committed or aborted. So in this state, no further action are required from the transaction as the database is now stable. So all these are the states of transaction states of database management system, and all these are the comes in the life cycle of transaction state. Let's take an example of transaction state. Imagine a bank transaction where a user wants to transfer 500 from account A to account B. The system should handle the following transaction states. Alright, so the first state will be active state. The transaction begins. It reads the balance of transaction amount account A and check if it has enough fund. If it has enough fund, read balance account A is equals to 1000. Alright. In partially committed state, the transaction performs all its operation but hasn't yet saved. Alright, so in partially committed, the data will not be saved. So committed the changes to the database. So example, deduct 500 from account A balance, like 1000 minus 500, which is 500, and temporarily update account B balance at 500. Next state will be committed state, where the transaction successfully completes and the changes are saved permanently in database. Example, account A now balance is equals to 500, account B new balance is equals to 1500. Changes are returned to the database. The next state will be failed state. If something goes wrong during the transaction, example power failure, system crash, the transaction moves to this state, and for example, system crashes after deducting 500 from account A but before adding it to account B. Alright, so the next state will be aborted state. The failed transaction is rollback and database is restored to its original state. Account A balance is restored to 1000 and no changes are made to account B. Now, the next topic will be serializability, which is so important in database system or management system. Serializability ensures the database remain correct even when multiple transactions run at the same time. So it ensures that data may remain correct. All right, so this is serializability. It makes transaction behave as if they were executed one after another in same order. This prevent conflicts, maintain data consistency, and ensure reliability results, just like in a single orderly sequence of transactions. So this is serializability. It is divided into two types: conflict serializability and view serializability. So the first will be conflict serializability. It ensures database consistency by checking if a non-serial schedule can be arranged in a serial order by swapping non-conflicting operations. It prevents conflicting operations like read write or the same data from executing at the same time. So this is conflict serializability. The next will be view serializability. Serializability is the important topic for exam point of view or for when you study TBMS. All right. View serializability ensures that a non-serial schedule result in the same final outcome as a serial schedule, maintaining database consistency. To further understand view serializability in DBMS, we need to understand the schedules S1 and S2. There are two transactions T1 and T2 should be used to establish these two schedules. Each schedule must follow three transactions in order to remain or to retain the equivalent of the transaction. These three circumstances are listed below. The first circumstance will be same transactions. Both schedules must include the same set of transactions. The next will be same writes. Each data item must be written by the same transaction in both schedules. And the last circumstance will be same reads. Like each read must read the same values from the same write in both schedules. So this is view serializability. The next topic will be recoverability and failure handling. So these are the things which are happened by or which we recover, like log based recovery, checkpoints and deadlock handling. So log based recovery is basically the database keeps a log or a diary of every changes. If the system crashes, it look at the log to redo, like we redo undo the things, these are happening there. So redo successful transactions or undo failed ones. The checkpoints will be points in the log where the system ensures all previous changes and safely return to the disk. This saves time during recovery. The deadlock handling will be when transaction A waits for transaction B and B waits for A, prevent using timestamps and detection using a wait for graph. So this is recoverability and failure handling. The last topic will be concurrency control, which is also very important. We have log based protocols, shared lock and like exclusive lock in log based protocol, and we have two phase locking, which is growing phase and shrinking phase. Let's talk about this. In log based protocol, we have shared locks, which means for reading only. Multiple user can have this. All right. Exclusive lock for writing, updating. Only one user can have this. So this is log based protocol we use in concurrency control in transaction concept. And two phase locking is growing phase, like transaction acquires all locks it needed, and shrinking phase will be transaction releases all locks, like crucial one, you release a lock, you cannot get a new locks. All the things are in unit 4 of database management system. If you like this video, thanks for watching.